Ignition sequence starts.
Good morning. You're looking at Mission Control Houston and the members of the Orbit 2 team of flight controllers who are keeping tabs on the systems of the International Space Station and working with the crew members as the 5 astronauts and cosmonauts wrap up their first full week on orbit together. Commander Chris Cassidy and his American and Russian crewmates have been focused on integrating the newest crew members into daily life on the station. That includes getting them acquainted with some of the science experiments that are underway, like one focused on improving our understanding of how and why hurricanes get stronger under certain conditions.
Welcome to Space to Ground. I'm Sandra Jones. This week, a science investigation is underway that could improve our understanding of hurricane intensification, and the latest space station crew members have been busy adjusting to life back in space. Not all science experiments aboard the International Space Station require heavy crew involvement, thanks to increasing automation and coordination with ground teams. The European Space Agency's Atmosphere-Space Interactions Monitor is one such example. This Earth observation facility studies severe thunderstorms and their role in Earth's atmosphere and climate using upper atmospheric lightning. This lightning, also known as transient luminous events or terrestrial gamma ray flashes, occur well above the altitudes of normal lightning in storm clouds and include phenomena with names like red sprites, blue jets, and elves. The space station's low Earth orbit provides an ideal platform for measuring upper atmospheric lightning. By studying upper atmospheric lightning, we can improve our knowledge of the effects of dust storms, pollutants from cities, forest fires, volcano and cloud formation, and electrification, as well as our understanding of hurricane intensification and the relation to eye-wall lightning activity. This insight could be especially beneficial back on Earth, as June 1st marked the official beginning of Atlantic hurricane season, and tropical activity is already underway. NASA astronauts Bob Behnken and Doug Hurley, the latest space station inhabitants, have been busy adjusting back to life in space following their historic launch on May 30th aboard the SpaceX Crew Dragon vehicle. They took a few moments to reflect on their new normal aboard the orbiting outpost.
It's going pretty well. We've just gone over our first week in space this trip and been very busy. We even got to work a little bit on Saturday fixing our treadmill. So all in all, it's been great. It's great to spend time with Chris. He's a great crewmate. And of course, Bob and I are just trying to get our space legs, and hopefully we can contribute to the science. And we're doing a lot of transfer with the HTV vehicle up here. And then we're getting ready for some EVAs at the end of the month. So a lot going on right now.
This week's question comes from Michael, who wants to know if you can see the International Space Station without the use of a telescope. Well, Michael, the space station is the third brightest object in the sky and is easy to spot if you know when to look up. Visible to the naked eye, it looks like a fast-moving plane. You can check to see when the space station is flying over you next by heading to the Spot the Station website. Keep sending in your questions using the hashtag AskNASA. We'll see you next week.
The arrival at the International Space Station of the first crew members to fly on a commercial space vehicle is a step into a new era of human spaceflight, and it'll help extend the continuous human presence in space that began when Bill Shepard, Yuri Gidzenka, and Sergei Kriklev arrived at this space station almost 20 years ago. Through the support of scientific research and the testing of a new fleet of vehicles, we are gaining the knowledge that is vital to our future in space.
The International Space Station, a football field-sized, million-pound laboratory flying around planet Earth at 17,500 miles per hour. It's our home in low Earth orbit and the bridge to exploring the far reaches of our solar system. A place to learn what it takes to live, to work, to thrive in space. Thanks to space agencies representing more than a dozen countries around the world, it went from the drawing board to liftoff when the first piece flew into space in 1998. That kicked off over a decade of construction, hauling the station to orbit piece by piece on NASA's space shuttle and Russian rockets. And after the first crew arrived in November 2000, we started an unbroken streak of humans living and working in space. Building on the legacy of past outposts like Skylab and Mir, the International Space Station became the training ground for humanity's next great journeys. Learning how to live in space for extreme periods of time, building and perfecting the technologies necessary to travel to our neighbors in the solar system. It gave us a place right on our doorstep to prepare for the next giant leap into the unknown. And thanks to the station, a new era in outer space is unfolding. What was once the domain of only nations and governments is now populated by a growing space fleet from American industry. Private spacecraft to fly cargo and crew members, new habitats and technologies for future space missions, and an open door for companies, research institutions, and even students around the world to do research in space that have never had the opportunity before. All laying the foundation for a robust economy in space. There have been thousands of experiments, hundreds of spacewalks, endless hours of challenges and successes, all done by humans hailing from countries around the globe. The International Space Station is what we can achieve as a planet when we come together to do the things that are hard. And the work isn't slowing down, because we're ready for the next giant leap, because we're ready to go farther, because what we do and learn along the way is for the benefit of all of humankind.
Part of the science mission of the International Space Station is to take advantage of the weightless environment in low Earth orbit to do research on technologies that can benefit future exploration, or life on Earth, or maybe both. For example, the station is home to the Refabricator, a 3D printer that can make things and then recycle them and 3D print new things with the same plastic.
The In-Space Refabricator. Presented by Science at NASA. While 3D printers are technology that many people are familiar with, there's one 250 miles above us on the International Space Station, or ISS, that's unlike anything currently found on Earth. It's known as the Refabricator, a hybrid 3D printer that can recycle its hard polymer plastic numerous times to make new items. About the size of a dorm room refrigerator, the device is controlled by operators on Earth who oversee its manufacturing via video cameras. Nikki Werkheiser, NASA's In-Space Manufacturing Manager at Marshall Spaceflight Center in Huntsville, Alabama, says, "Recyclers on Earth grind plastic pellets to create their products. But that grinding creates material shear, which prevents you from reusing that plastic again. It's no longer strong enough." For this technology demonstration, the company, Tethers Unlimited, developed a novel recycling process that doesn't require grinding, and that allows us to recycle the plastic multiple times. The ability to reuse the plastic over and over again is essential for long-term space exploration. Werkheiser says, "We can replace a lot of the things we need when we're orbiting above Earth. We just have them delivered on a resupply mission. But when you're in deep space, you don't have that option. You have to have the ability to make all the parts you might need, and without having a large stockpile of extra materials." The Refabricator can even recycle plastic items not normally associated with Earthbound 3D printers. For instance, almost all of the materials that are delivered to the station are packed using foam or plastic bags. Both can be loaded into the Refabricator to deliver items such as a plastic syringe, an eating utensil, or a custom-made wrench. That ability limits the amount of backup materials you need to take with you on a long-range expedition. After all, in space, space is at a premium. The Refabricator's technology demonstration will be composed of 2 phases. During each phase, The refabricator will perform 7 cycles of recycling and printing parts while on board the ISS. All of the items printed by the refabricator will eventually be sent back to Earth for testing and analysis to determine the effects of repeated recycling on the material properties of the plastic. Werkheiser notes, "I'm very excited about this technology both in space and back on Earth. I can envision a day where you go to the grocery store and drop your water bottles and plastic bags into a refabricator, and then select your new phone case, or a kitchen gadget, or the raw filament that you can use in your 3D printer at home." For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more information about how the promise of future exploration is transforming today's technology, visit science.nasa.gov.
International Space Station crew members are the test subjects in some of the onboard research as scientists study how being in space affects the human body. And that includes studying how the crew members establish a routine for sleep, which is a key to their being able to function to the best of their ability. In this demonstration video, astronaut Ricky Arnold talks about some of the problems with sleep in space, and he shows us how the astronauts overcome them.
Hi, my name is Ricky Arnold on the International Space Station. We get asked a lot, how do we sleep in space? And it's a great question because we all know how important a good night's sleep is. If you're not getting a good night's sleep, you can count on reduced cognitive function, poorer reaction times, and maybe just being a little grumpy. And up here in space, just like on Earth, those are things we all want to avoid. So, we go around the Earth about every 90 minutes, which means we get 16 sunrises and sunsets a day. So how we sleep is a really good question because the sun's always getting ready to come up or it's getting ready to set. And we use those cues on Earth to let us know when it's time to begin our day and when it's time to end our day.
Ricky is talking about circadian rhythm. It's the body's natural regulator for sleep and wake cycles based on a 24-hour schedule. Those 16 sunrises and sunsets he mentioned can cause circadian misalignment and sleep deficiencies during long-duration spaceflight. The hazards of lost sleep can range from poor attention at school to on-the-job errors to long-term sleep loss, even chronic disease. Sleep is super important. Hey Ricky, what are you doing on the space station to get some sleep?
Well, here in space, we kind of have to do it artificially. So we have these nice crew quarters. It's about the size of a refrigerator. It's very quiet. The space station can be a little noisy, but it's very quiet in here. And we can control light with a light switch. If we are just middle of the day, we have a light like you're seeing right now, which is just this kind of standard lighting. It's getting close to the end of the evening. You want to dim the light a little bit, kind of for the end of the evening. Or if you're going to be up late, you need to keep awake, we have a really bright light setting. The other thing we have is off. You see how dark it got. Another challenge sleeping on the International Space Station, sleeping in microgravity is really nice because you can just float and stretch out and it's really comfortable. The problem is with the air currents in the International Space Station, you could very well float into a piece of hardware and hit your head, or worse yet, even break something. So we got our sleeping bag here, just almost like a sleeping bag on Earth. But as you can see, we have bungee cords that help hold us up against the wall, so I almost sleep standing up. And also, I do have a pillow. It's just a bag full of clothes, but I actually keep it up on the top of my head because I'm a little tall. In the crew quarters, I tend to hit my head on the ceiling when I'm sleeping. So I got my sleeping bag here. I got my bungee cords to hold me in. And then when it's time to go to bed, it's quite easy. Just unzip the sleeping bag, climb on under the bungee cord, climb into the sleeping bag, make sure you're nice and secure, zip yourself up, plan on getting a good night's sleep so I have good reaction times, my cognitive ability is what it should be, and that I'm not grumpy in the morning. So with that, I'm all set. Good night from the ISS.
The scientists who developed the experiments being done on the International Space Station spent years getting them ready to fly, and then worked with the station crew members to explain how they will help execute the science protocols. In the next episode of the new NASA Explorers series, we look in on this step in the process for one team of scientists when their experiment reached the station and the expedition crew members opened the package.
Choose your lettuce leaf. Cheers. Cheers. We get balsamic? Oh, that's pretty good.
Wow.
It's a salad. It's a salad. JC, that was delicious.
Feel, Serena, that sounds great.
Well, when you haven't had a salad in 6 months, it's delicious.
Still station on 2 for Nanarax.
With you on 2 for Nanarax.
Right, how's your view? Do you want anything different?
View looks great.
No, the view looks great, thank you.
Now that the experiment is aboard the space station, it's time for the astronauts to get to work. Elaine and Paris Stu are back in Virginia, and the Nanarax team is back in Texas, where they will perform a ground control version of the experiment being conducted by the crew in space.
The crew members are using the Nanarax plate reader to read the plates. They're analyzing what's in the plate and the migration of fluids between the 2 chambers that are on the plates. And so we have our ground samples here. These are identical to the ones that are on the space station. And what we're going to do is, as the crew members insert the plates into the plate reader on the space station, we're also going to insert the plates onto the ground unit we have behind me. And that's just to confirm that what we're seeing, any effects that we do end up seeing, is effective the space environment compared to the ground unit. In summary, what the plate reader does is, it's called, the big fancy word is a spectrophotometer. And it's got a big lamp in it that shines white light, and then it's got a prism or a grating. And the white light shines on the grating, and then it moves to orientate to kind of separate the light into a wavelength. And you get to select which wavelength you want to shine through your samples. We have 6 plates. Each plate takes about 4 minutes, so it's about 30 minutes each. And every time in between, we'll be listening for the crew member to say that they inserted the plate. Then we'll hit the command here. Once the run is done, the crew member will come over and take the plate out, put the new plate in, and it'll repeat for 5 more times.
Still station on 3, plate 1003 is in the tray.
Oh yeah, it's reading the plate. It's got a little, the plate sits in there, moves the plate this way, and then the read head moves this way. And a little here, that's kind of the lamp that's in there that turns the lamp on. Sounds like bad techno music.
My crewmate actually was the first one to start this experiment, and I took over for him and said, hey, what experiment is this? What are we doing? And he looks at me and he says, I'm not sure. So we called down to the ground to mission control.
And I know that part of this is we're looking at a gel that can release antibiotics, kind of slow release to a wound site. But I don't know what happened to that plate in the Nanarax reader this morning, and then kind of what's going on this afternoon.
What we're looking for is how the drug migrates through the gel over time, which is why we're scanning the plates 2 times a day for this 2-week run.
I like that answer. That's very cool. Thank you for finding that out.
No problem.
So this is 15 days. It's twice a day, and they're typically in the middle of the night, which is the morning for the crew on space station, and then usually sometime in the late morning, early afternoon here. But Kyle's been running the show. He's been getting up every 6 hours, 8 hours, 7 hours to do this. It's kind of fun in a way. I get to play astronaut on the ground, so that's always fun.
After 15 days of running the experiment, the researchers have a lot of valuable data about how hydrogels behave in microgravity. To learn even more, the samples will come back to Earth for further analysis. For the last leg of their journey, the samples will return to Earth in the same Dragon capsule that gave them a ride to microgravity. After Dragon splashes down in the Pacific Ocean, it's taken to the port of Long Beach, where NASA will be ready to retrieve the precious cargo.
Splashdown for Dragon was on Sunday, I believe. And so NASA has a group called Cold Stowage and Cargo Manifest, and they go out and pick up the payloads from Dragon. And then they distribute it to people at LA or whoever needs them there, and then they bring them also here to Johnson Space Center. And so now I'm out front at the Cold Stow office, and I just picked up Module 74, which is our Tympanogen project. And they hand it to me, and I put it in my cooler, and then I drive it over to our office where it's going to sit until we fly up to the Tympanogen office in Richmond, Virginia to do the final phase of the experiment, which is removing the samples out of the reactor microplates. We're really proud to take part in this really interesting experiment.
When we first got our gels back, it was already exciting because space never loses its cool, and so we had these places where, oh my god, these are what the astronauts touched. And so we opened up and they've been to space and back, and now they're in our lab.
In all of the work being done inside and outside the vehicle, the International Space Station is helping us know what it will take to make successful journeys out into the solar system one day, to Mars and other destinations. Here are a few more examples of how the station is building the missions of the future.
So you want to go to Mars. How does NASA's International Space Station help us extend human presence into deep space? In the future, when astronauts land on Mars, it will be thanks to some important lessons that we learned on the International Space Station. Rewind. 240 miles above the Earth, the International Space Station is where we currently live and work in space. Here's what we've learned so far. First, there's taking care of our astronauts. Prolonged weightlessness can lead to muscle and bone loss, vision changes, balance, and coordination loss. Thanks to the space station, countermeasures are being developed to keep astronauts healthy for long-duration missions. Then there's the equipment. Spacecraft communication, water recycling, air, and power production are all being test-driven on the International Space Station. What we learn about operating and maintaining our gear in the harshness of space will pave the way for future missions into our solar system. And that's how the space station is helping us extend human presence into deep space. For more information, visit this NASA website.
The opportunity to spend 6 or so months on the International Space Station, as men and women from around the world have been doing without interruption for more than 19 years now, has led to the development of new technologies for space exploration, groundbreaking scientific discoveries, and an experience of cooperation among nations while fostering the commercialization of space and spaceflight. But even more than that, it has caused many of those astronauts to experience a shift in their worldview. NASA's Karen Nyberg is one of them.
My first flight was 2 weeks, and a lot had to get done. I distinctly remember the point when I stopped and thought, I did it, I'm here. My goal was to be an astronaut, and now I'm in space. I remember seeing the beauty of Earth, but I don't remember any more profound thoughts about it at that point. I think it was when I got into my long-duration flight and spent a little more time that I really just started to take it in a little bit more. The entire experience is actually very surreal. First, you're launched on a rocket. You're pulling G's as you're going out of the atmosphere. You're looking at the Earth for the first time. You're floating. Everything is different, and it just is all just such a different experience that it almost doesn't seem real. In fact, when I did my space shuttle flight for 2 weeks in 2008, when I got back, you could have convinced me I never went, probably, if there weren't pictures. This experience is so unusual and so different than anything you've ever done in your life that it's hard to grasp it all. And I was very excited then when I got assigned to a long duration because I thought it's going to burn in my memory and all that. And it was the same thing. I came back and my memories were there, but it almost didn't seem real. Looking at the Earth for the first time, you just notice the vibrancy of it. It's so bright. Pictures don't do it justice. It's equivalent to me of backpacking out in the mountains where you're trekking along and then you come to a clearing and you're overlooking some valley and the sun is setting and it is, you know, you're like, how could this get any prettier? And you take a picture and then you go back and look at the pictures later and you never have that feeling again. It never brings about the feeling that it did. And same with watching a beautiful sunset or a sunrise. I have not seen a picture that gives me the same feeling that I felt when I looked with my own eyes. It started to make me understand that everything is connected. What is happening in the ocean over here can affect what is happening on land over here. It's just all one being, and it's all interconnected. And so I think we tend to live in our bubble of our world that's here, and it's hard to think about other people on the other side of the world and be empathetic toward them, really, because you don't know them and you don't know their situations. And I found seeing the Earth really changing that perspective for me. And then listening to a news story in the morning and flying over that particular part of the world in the afternoon, it really affected me. And then just realizing, I mean, it's home. Often we think home, and you know, right now home is Houston, Texas, and childhood home is Minnesota, but home is Earth.
If you'd like another look at the stories we feature today, check us out on YouTube and Facebook. The addresses are right there. Be sure to look around. Take a peek at the other cool stuff you'll find there about NASA and America's human spaceflight program. Now, if you're interested in good conversation about human spaceflight and space exploration, check out Houston, We Have a Podcast, where we talk to folks about their work in all aspects of space exploration. We post new episodes every Friday. Today, Gary Jordan talks with two Canadian television producers and storytellers about their work to capture life on the International Space Station in virtual reality that you and I may soon get to experience ourselves. Go to nasa.gov/podcasts for this week's episode. It's also where you'll find all our previous episodes, plus the full library of all the NASA podcasts, all of which you can listen to on Apple Podcasts, Google Podcasts, and SoundCloud.